Will the Los Angeles Lakers win their next game? Hey there, I'm Stuffed Code, and today we're diving into that exact question. We'll be using real stats, a dash of AI, and some good old-fashioned logistic regression to break it all down, like a basketball scientist in a lab coat. From points per game, opponent defense, to recent win streaks, we're crunching the numbers and letting the math do the talking. So whether you bleed purple and gold, like me, or you're just curious how data can predict the game, hit that like button, subscribe, and let's get into it. So here's the thing. Is just knowing each team's win percentage enough to predict their next game? Not really. A ton of variables play into a single match. Injuries, matchups, momentum, even whether LeBron's rocking that headband that day. You know what I'm talking about, Laker fans. While some things will always be outliers, data at scale helps us start to find patterns. And with enough of it, we can begin to build something pretty cool. A model that actually makes sense of the chaos. But for now, we're going to keep it simple and we're going to use some classification. What we're really asking here is a yes or no question. Will the Lakers win their next game? That makes this a classification problem, not a regression, not point spreads, just binary outcome, prediction win or lose. So how does that work? Well, we train a model to learn which combination of stats tend to lead to wins, and that's where logistic regression comes into play. It's a simple but powerful machine learning model that takes our input stats and returns a probability. Basically, based on this data, let's say there's a 74% chance the Lakers will take the W. That's all it does. No sorcery, no guessing, just math plus pattern recognition. So what kind of data are we actually feeding into the model? Let's take a look at ourselves. Well, first, we're taking a look at Lakers' average points per game, opponent's defensive rating, current win streak, star player availability, home versus away status. These features help us build a context before the model does its thing, and sometimes bringing in a little human intuition can help validate what the model is seeing, or at least challenge it. So take a moment, look at these stats, and think, what would you predict? Alright, we looked at the stats, made some human guesses, now let's see what the model thinks. Here's how it's gonna work. We're gonna take those stats and plug them into this equation, which is the logistic regression equation. Each stat, like points per game or win streak, has a weight or a coefficient based on how much it influences the outcome. For example, scoring more points, that's going to add a positive weight. Facing a tough defense, that might lower your odd, which is going to be a negative weight. Playing at home, probably a slight boost because you don't have to go out, fly to your opponent and whatnot. These weights were learned from past data using a process called maximum likelihood estimation. Basically, a trial and error until the model figures out what pattern leads to wins. So, when we plug in the numbers for this upcoming matchup, we get a value of, let's say z equals 1.1. And then we pass that through the sigmoid function, and then we get this, which will be x equals 1.1, and then y roughly equals 0.75. And then when the probability of that winning is 75%, boom. The model says the Lakers have 75% chance of winning their next game. It's not guaranteed, but it's data-backed prediction you can feel good about. However, these numbers are all exemplified. So before we actually get into the real data, I just wanted to give you guys an example of exactly how it's going to look, or how the application, is going to be basically doing the calculation. Alright, so if you were to actually go ahead and take a look at the code itself to see, how everything is going to basically fit with the coding and, the logistic regression. Well, first we're going to be using the NBA API, and with that, we're going to be going ahead and getting the stats for the Lakers itself. So we're going to be only getting the last 77 matches, season only. So we don't want to go back to different years and so forth. Now, one thing that you could actually do is get the total season when AD was with the Lakers, and then when Luka joined, you could totally do that as well. Separate out the games, get a different percentages, and then put them all together. So there's going to be some fluctuations, of course, because we're going to be only taking the 77 in seasonal games currently. That's that has happened. So with that, once we get the Lakers stats, we're gonna be putting them into something called a data frame. We're gonna be using pandas for that. And data frame, you can just think of it as like an Excel spreadsheet basically, and it's gonna be of course within the code itself and within the memory. And we're gonna be initially then just like I was talking about, we're gonna be getting the defensive rating for the Lakers, and not only Lakers but it's it's matchup basically, where it's gonna be like versus Boston or versus Phoenix or whatever, and we're gonna be getting its matchup, and it's gonna have the its defensive rating right next to the the matchup itself. Like if you will have the column and the row, that's basically where it's gonna be. And we're going to be mapping the abbreviations for the full team name, because that's basically what we're going to be matching up against, and we're going to be merging that back into our original data frame. And then we're going to get the win streak, whether this is going to be either positive or a negative basically weighing on it. Now we're only doing the win streak. Now you could also go one step above and do like a losing streak as well, where it could be like, hey, this is how many times they lost in a row, and this is how many times they won in a row, and etc. You could get a lot more deeper in here. We could just say that this is pretty simple compared to data analytics. So we're only going to be focusing on the star players. I typed in star players available, but I'm only going to do LeBron for this experiment. You could actually do more. You could do like LeBron and AD before AD left and Luka joined. You could do LeBron and Luka. You could do AR-15 in there. You could do different role players also added in there as well, and see who's playing and who's not, and what the win percentage is based on each player playing. And we're basically analyzing our next game and so forth. And this is where the meat of the model itself. So we're gonna be here training the logistic regression, where our features are actually is gonna be part of our coefficient itself in our logistic regression formula. You can basically think of it as the sigmoid, the beta icon, and then that's going to be our features, our coefficients. It's going to be part of our weighting, the weight itself based on what each of the outcome is going to be. And from there, we're going to be then training our model itself. We're going to be doing the x and y test split, and yeah, we're just gonna be going ahead and evaluating the model afterwards. And so yeah, let's go ahead and see the accuracy and what the prediction is gonna be. So let's just give it a try. So if we were to just take a look at the win probability itself, it's saying that it's gonna be 61.9% win for the next match itself. However, the accuracy itself isn't great. We had a small subset of data. 77 is not that much at all, right? So we have a small subset of data, and it's not that big. But what's really worrisome is this is basically saying loss and wins, right? It's only basically calculating wins itself. It's ignoring the loss itself, right? So this is basically it's an imbalance of data ingestion itself. So there's other stuff that we're gonna be able to go ahead and modify here and there. But basically, if you wanted to get fancy and utilize stats and checking out and see if Lakers or your favorite team can basically, if they're gonna win, you can go ahead and utilize a logistic regression to basically check and see if they're gonna be winning or not, just for fun, for an exercise. But yeah, so with this, we didn't have that much data, and we as you can see, the accuracy is 0.6, which is not great. I would have liked to see that as a much higher accuracy, but it kind of does make sense with with the data that we have, and kind of like a hacky solution that we have put together, or I have put together. So yeah, in our hacky solution, we're saying, you know, the win probability of the next match is 61.9. So we'll see if they're going to be able to beat OKC. So in short, the model's pretty decent at spotting wins, but again, it was lacking in spotting losses, which is kind of huge. You know, it's basically, you know, thinking that Lakers are going to win all the time. As a Laker fan, I would love that, but we know that's not going to be the reality. So hopefully we can basically in the future, if you want to give it a try, or maybe in, you know, different future videos when I do different data analytics, we could go ahead and tweak our model, get more data, you know, maybe, you know, merge and aggregate some of the other data that we could think of. But yeah, so from there, basically, we just try again and see if we're going to be able to go ahead and get a higher accuracy, higher than 0.6, and just go from there. But yeah, thank you for watching the video. If you liked it, don't forget to press thumbs up. If you didn't, do the thumbs down and let me know why, and then I can improve upon it. If you want to see more, you know, NBA analytics or just overall data science and whatnot, AI, don't forget to subscribe. It will really mean a lot. So that's all, and hopefully see you next time.